This is rheostat voltmeter with 0.1 list count, and this is ammeter with 0.05 list count. This is battery eliminator, and this is the circuit. What we need to do is, first of all, switch on the circuit. And keep on sliding rheostat. What we have to do is, we have to calculate resistance per unit length of this material. For full scale resistance on rheostat, the voltage and current in voltmeter and ammeter respectively are. We have to note this down. Then change the resistance in rheostat and again observe the voltmeter and current reading. Before that, circuit should be switched off for some time, either for 30 seconds or 1 minute, so that effect of temperature or heating can be ignored or avoided. Then switch on the circuit, take the observation. Again switch off the circuit, change the resistance, and again switch on the, again take the observation in voltmeter as well as ammeter. We can observe that with change in resistance on rheostat, reading in ammeter and voltmeter keep on changing. We have to take 10 readings of voltmeter and ammeter of potential and current, and have to calculate resistance of each observation. That should be constant. And then we have to calculate resistance per unit length. For that, the length of resistance wire will be measured and divided to the resistance. V versus I graph should be straight line passing through the origin. Hence this experiment completes.